Number 3. It says an automobile travels on a straight line for 40 kilometers at 30 kilometers per hour. So I'm just going to draw a line. And this will be 40 kilometers distance. And that is traveling at, it's at 30 kilometers an hour, correct? Okay. It then continues in the same direction for another 40 kilometers at 60 kilometers an hour. So we go, put a little split there, another 40 kilometers. And now we're going at 60 kilometers per hour. And then it asks, what is the average velocity of the car during the full 80-kilometer trip? Okay, so we have the parameters of the problem laid out. If I have this here, what we want to do is break this up into two parts. And we want to use the physics equations we learned in this chapter, right? So one of the ones we can use that is in that list of 5 equations that I showed you before is the x final minus x initial, and this marker's already going, equals v naught times t plus 1/2 at squared. So we have this problem here, and you say this looks big and complicated compared to what we have, but what you want to do is make a table. And so we have like basically the initial velocity is 30 kilometers per hour, but it's also the final velocity. It just happens to be the same, but we're going to leave it as v naught since that's the equation. V naught equals 30 kilometers per hour. We also have x final and x initial. X initial in this case would be 0, which a lot of times it is. And then x final will then equal 40 kilometers, because we're only going to do this first part. And then we'll do the second part the exact same way. Okay, so we have that. Now we go on and we look through this. We don't have t. And then a. A is 0 because this is moving at a constant velocity, right? So A equals 0. So now you have your table. We see what we're looking for, times the missing variable, and then you have the information for the rest of this stuff. So if we fill that in, you have your x final, which is 40 kilometers, and I made it look like a P or something. So you get 40 kilometers equals the velocity, 30 kilometers per hour times time, and then that's plus 0, right? Because this whole piece just gets wiped out. Okay, so all you have to do is then solve for t. T equals 40 kilometers divided by 30 kilometers per hour. Kilometers go away. And then when you do this, you should get 1.33 hours. So now if you do the exact same procedure with this guy, all we're doing is replacing this 60 kilometers per hour. And so then you're just dividing 40 kilometers over. So this is part 1, and this is part 2. So you get time, we'll call it time 1 and time 2. So then we'll say 40 kilometers divided by 60 kilometers per hour. And then you should get 0.67 hours. So all we do is add these up. T1 plus T2 equals 2 hours. So that gives us the time. Then just to do a V average, we're just doing the total trip, basically x1 plus x2. and we are dividing that by the total time, the change in time, which is 2 hours. So we'll say T1 plus T2. So this is still in there. I'm gonna make this back over here because I'm running out of space. So you should get 80 kilometers divided by 2 hours. So you get 40 kilometers per hour. So this is the average speed. Since we were moving in this direction along the positive x-axis, this is basically the answer for part A. For part B, you basically then just get plus 40 kilometers per hour. And remember, to get the vector, we need a direction. So that plus is giving us a direction. So this is the direction. This is the magnitude. This is a vector. So this is the answer to B. So I'm going to do a real quick graphical representation. Hopefully this stuff is obvious and you already have it. But we will do the sort of your change of x-axis, and I'll do 80 up here, 0 down here. And then we can do up to 2 hours, so this will be time. And that's in hours, and this is in kilometers. Right, so I'm going to do this real rough. So if I do, we'll say 1 is here, 1.5, 0.5. So if we do the first one, it took a little bit less than 1.5, so, and we went up to 40, so I'll do a halfway mark here, 40. So from 0, so basically we went about 1.33, somewhere around here. We went up to 40 here, and we'll go here, and then hopefully up. That way, because there should be a separation, it's accelerating more here. It's just poor drawing. So if we look at this, then if you add up tip to tail, that's basically the total vector of the entire trip, right? So again, do the graphic on your own. Hopefully it makes more sense when you do it by yourself. I hope that was clear. If it's not, again, email me.